All right, Chapter 9 is the last chapter that we're going to do for the course. We're going to look at estimating the value of a parameter. More specifically, we're going to talk about confidence intervals in this chapter. Okay, and we'll look at that here. Definition, if we do not have access to the entire data in a population, then we cannot determine the values of population parameters such as mu or sigma. Therefore, we use sample data to estimate the values of the parameters, and these estimators are called point estimators. For example, x bar, the sample mean, would be the point estimator of mu, since that number would be the best estimate of the actual population mean. The sample standard deviation, S, is a point estimate of the population standard deviation, sigma, since that number would best estimate the population standard deviation. Okay, now there's only two sections that we're going to cover here in Chapter 9, 9.1 and 9.2. So we're going to first talk about confidence intervals about a population proportion in 9.1, and then in 9.2 we're going to look at confidence intervals about a population mean. Okay, so again, the topic is confidence intervals, but it's we'll look at proportions first. Another definition, suppose that you are interested in a characteristic or feature of a population where every individual has or does not have this characteristic. To investigate this characteristic, you take a simple random sample of size n from the population. The portion of the population that has this characteristic is denoted by p, and the best point estimate of p is the sample proportion of individuals that has this characteristic, which we're going to denote by p hat. Okay, and of course we've seen the symbol p before, right? With the binomial experiment, p represented the probability of a success in a binomial experiment there. So, all right, here's an example. Suppose that you conduct a study of 1,000 U.S. adults, and you ask the question, in your opinion, who is the greatest president? Of those that were surveyed, 195 responded Abraham Lincoln was the greatest president. Of the remaining 805, they mentioned some other president. Okay. Now suppose that we wanted to know the parameter and the point estimate in the study. The parameter would be the proportion of all U.S. adults who believe that Lincoln was the greatest president, which is actually something that we will never know. Okay, there's no way to survey everybody who has ever lived and ask them this question: who is the greatest president in the United States? Okay, so we will never know that true percentage, which is the parameter. Okay, now the point estimate in the study would be the percentage of those who said yes to Abraham Lincoln. So p hat would be, if I take the 195 who said Lincoln out of the 1,000 that were in the study, 19.5% said Lincoln was the greatest president. Okay, now one thing that I would want you to notice here, suppose that you were to actually survey the entire population and ask everybody this question: who is the greatest president? Do you think it would be that 19.5% would say Abraham Lincoln? Do you think that would be an exact percentage? I would say probably not. Okay, so the idea with this section is we're going to give an interval of numbers where we think the true percentage is going to lie. Okay, and that's going to be kind of introducing the topic of a confidence interval here. Another definition is, so a confidence interval for an unknown parameter consists of an interval of numbers based on a point estimate. The level of confidence represents the expected proportion of intervals that will contain the parameter if a large number of samples is obtained. The level of confidence is denoted by 1 minus alpha times 100%. So like, for example, if you had a 95% confidence level for a particular problem, alpha would be 0.05, since 1 minus 0.05 is 0.95, and 0.95 times 100% would give you the 95% level that you're working with. We're going to have to identify alpha in some of the problems later on. Okay, and that would imply that if 100 different confidence intervals are constructed, then we would expect 95 of the intervals to contain the parameter and 5 not to contain the parameter. Okay. There's a note: the most common confidence levels used in statistical studies are 90%, 95%, and 99%, although any level of confidence from 0% to 100% is possible. Okay, but these are going to be typical confidence percent levels that you'll be seeing in the problems. Let's take a look at problem 1. Suppose that you wanted to know the proportion of students at ICC that drink coffee daily. Part A, make an educated guess as to the proportion of students at ICC that drink coffee daily. So I just made a guess here. Suppose that I'm going to guess that 65% of all ICC students in a given semester, full-time, part-time, whatever, any age, 65% would drink coffee daily. Okay, now how sure can you be that your guess is exactly correct? Well, if I were to survey the entire ICC student population, I think it would be unlikely that I would be exactly correct at 65%. I mean, it could happen, but 65% is just a guess, you know, and it's easy to guess wrong. Part B, give a range of values where you are completely 100% confident that the true proportion P lies. Well, to be completely sure, we could say 0% to 100%. In other words, I am 100% sure that if I were to survey the entire ICC student population, between 0% and 100% would say that they drink coffee daily. Okay, like I'm 100% sure of that. Now, part C, give a range of values where you are 75% confident that the true proportion P lies. So I just made up an interval here. You know, the interpretation of this would be to say I'm 75% sure that if I were to have surveyed the entire ICC student population and ask or figure out who drinks coffee daily, I'm 75% sure that that percentage would be something between 50% and 99%. Okay. Now, the margin of error is another term that we're going to need to know here. We're going to call that E. The margin of error determines the width of the confidence interval, how wide the interval will be. There's a note there. The more confident that you want to be, the wider the interval, and vice versa. Okay. If you're going to be more confident in a statement, you're being more risky in making a mistake. So that's why the interval is going to get wider, because the margin of error will get wider. Let's go to the next page here. And there's a note. Now remember that the population proportion P is an unknown value. Okay, in every single one of these problems, we do not know the value of P. We're trying to figure out where that's located, though. Okay, confidence interval estimates for P are of the form P hat plus or minus E. Okay, so you're going to take the point estimate, P hat, and then add and subtract the margin of error to get the what's called the lower bound and the upper bound. The lower bound is where you take the point estimate and subtract the margin of error, and the upper bound is where you take the point estimate and add the margin of error. We can also describe the interval using interval notation like you'd see in an algebra class. This is going to be the notation that you'll see in the book with parentheses and a comma between. Okay. So let's take a look at problem 2. It says that a Gallup poll of 1,028 Americans age 18 and older conducted in 2013 asked the question, do you think the use of marijuana should be made legal or not? I probably need to update this problem. But Gallup reported that 58% of Americans aged 18 and older say that the drug should be legalized. The margin of error was 4 percentage points with a 95% confidence level. Okay, so this is a real study that happened in 2013, just like many of the other problems that we've been working with. It is real information, real data. Okay, and this is how Gallup, which is a big-time statistical research organization would present information. Okay, what does this mean? If somebody were to read this statement, well, they're using a 95% confidence level. So the interpretation of what was studied here would be to say that we are 95% confident that the proportion of all Americans age 18 and older who say the drug should be legalized is somewhere between 54% and 62%. Okay, the 58% is just coming from a sample. Okay, the sample was given to us here, and so based on this one sample, we're going to make a statement about if we had surveyed all Americans over 18. Okay, what would that look like? There's going to be a margin of error of 4 percentage points. And we'll talk about how we get the margin of error and all that later. But in other words, if you were to survey all Americans 18 and older, like I highly doubt that it would be exactly 58% that would say, yeah, the drug should be legal. Okay, but we're 95% sure that between 54% and 62% would say, yeah, go ahead and legalize the drug based on this one study here. I've got a note up above. This was actually the first time that a clear majority of Americans, that is more than 50%, said that the drug should be legalized. Gallup has been asking this question every single year. Some of their questions are like hot topic questions, and they ask them often because the public opinion changes, and they'd like to see the trends. But it was so this question has been asked every single year, going back to 1969. And back in 1969, only 12% had favored legalization. So you can see kind of the trend of over time. We're now at 58% in the year 2013. Okay, below that is the information on how to construct a confidence interval. We're going to, to construct a 1 minus alpha times 100% confidence interval for a population proportion, suppose that a simple random sample of size n is taken from a population of size capital N. The first thing that we're going to do is we're going to compute the point estimate, which is p hat, by taking x divided by n. X is the number of individuals in the sample with a specific characteristic. N, of course, is the sample size. Now, there are two conditions that need to happen before we compute the interval. Condition 1, it must be the case that n times p hat times 1 minus p hat is a number that is greater than or equal to 10 in order to construct this interval. Also, the sample size must be no more than 5% of the population size. Okay, so in other words, in these two conditions, you want to make sure that the sample is big enough, but not too big. Okay, once you've verified those two things, you're going to then determine the interval. Okay, now there's a note below that the standard normal table, this table that we've been using a lot here for various other problems, that table would be necessary to have if you were to construct these confidence intervals by hand. Okay, but we're going to omit the table and focus on constructing intervals by using the calculator. In other words, we're going to have the calculator do a lot of the dirty work here in getting the results. There are formulas in the book. You can look at those if you want, but we're not really doing much with formulas here in these sections to finish things off. Okay, like I said, we'll be doing a lot on the calculator. So I'll stop the video here, and I'll work through some examples in the next video.